I'll start with the first section of our webcast, which covers codes, guidelines, and standards for lighting. And the next two slides are common resources, and everyone should have access to the PowerPoint and will be able to click on these links to bring up additional details on these resources. I'm not going to go through all of these, but I will pick out the ones that are the most common for codes and standards. And the second page is some additional resources. Okay, so let's get into it. Energy codes. What code applies? So usually the first thing you want to do is check the local government website listing building code requirements. We all have access to Google, and usually that's the best way to start. There's also the U.S. Department of Energy has a website, energycodes.gov, that you'll be able to access with the slides from the previous slides. And that tells you, when you go to that website, you could pick what state you're in, and it will tell you the energy codes that apply. And there's also a link to download the ComCheck and ResCheck. Those are the compliance forms that you would use to show that you're complying with the energy codes. It's important to note what year or which year for any given code or standard has been adopted. For example, I'm in Ohio, it's 2020. However, Ohio uses the 2012 IECC, which is the International Energy Conservation Code. We'll talk more about that later. And the 2018 is the latest version of the IECC. And there's also ASHRAE 90.1 that Ohio also allows, but it's 90.1 2010. Even though 2019 is the latest version, Ohio, the current code is 90.1 2010. Some cities and counties adopt energy codes more stringent than the state level, so that's something to be aware of. In Ohio, we're pretty fortunate that all cities have to comply with the Ohio Building Code, which simplifies things. And probably the most important thing when you're going with your design is to make sure that you coordinate with the design team, the architect, the mechanical engineer, and the electrical engineers, which code is being used. For example, the design team may be, let's say there's a project in Ohio. We had an instance once where the architect was using the IECC and the engineering team was using ASHRAE 90.1. And then that wasn't discovered until at the end of the project. So that can cause some issues. So the key is just to make sure at the beginning of the project that everybody is on the same page as to what energy code is being used. Okay, next we're going to talk about ASHRAE standard 90.1. And ASHRAE updates this every 3 years, and we just talked about 2019 is the latest one. And similar to the IECC, it covers most aspects of energy efficiency in buildings, including lighting, and there's a number of other systems that are listed on the slide as well. And some jurisdictions adopt this code and also publish their supplemental/amendment. So it's really important to check that. In Ohio, for example, with ASHRAE 90.1 2010, they actually have an exemption for the 50% controlled receptacle requirement. So what that means is that ASHRAE 90.1 2010 requires at least 50% of all receptacles to be controlled by an occupancy sensor or time of day device. But Ohio exempts designers from having to comply with that. And that's for lobbies, conference rooms, offices, hotel, motel, guest rooms. Now you could have an instance where you're exempt from that, but then you could have another guideline or standard such as LEED, which if you're designing for a LEED building, you have to comply with the entire ASHRAE without any exemptions. So you just want to make sure that if you are designing a LEED building that has some ASHRAE exemptions, that you design it for LEED. Okay, next we'll talk about California Title 24. So California has their own energy codes and for lighting, and it's called Title 24. And it's one of the only energy codes that's not directly based on ASHRAE 90.1 or the IECC, and that's updated every 3 years. Some things that are unique to the Title 24, corridor lighting is to be reduced 50% when unoccupied. And also, they have a demand response capability, a minimum 15% reduction in installed lighting power. What that means is if the utility needs to have energy reduction based upon demand, so to prevent brownouts and blackouts, they require for buildings over 10,000 square feet. For example, a network lighting controller would receive a signal from the utility, and then it would automatically reduce the lighting by 15%. And this code is also available online. Okay, next we'll talk about the International Energy Conservation Code. And this is similar to ASHRAE 90.1 in that it covers everything from buildings. This actually covers buildings, fire, mechanical, plumbing, etc. And jurisdictions adopt each code individually, but typically adopt the entire suite of codes together. The IECC updates every 3 years, and the most recent is 2018. And like ASHRAE 90.1, it covers most aspects of energy efficiency, including lighting and the other building components. And the jurisdictions adopt this code and publish their own supplements and amendments. And we discussed some of these previously. So the IECC does have a section that allows you to use ASHRAE 90.1 as an acceptable alternative compliance path. So that means that teams have the option of using either one. And if you are using the 90.1 version, you want to use the one that's 2 years before the IECC version. So for example, in Ohio, the IECC version is 2012, and that would be ASHRAE 90.1, 2010. And again, just a reminder to check with your design team to make sure that everybody is using the same energy code. Okay, the National Electrical Code, I want to talk about that. It's updated every 3 years, and it's usually codified by a local jurisdiction. It's different than energy codes in that the NEC provides requirements on how equipment such as lighting fixtures are manufactured and installed. So it's not necessarily an energy code. So an example would be the can lighting. We have a picture of some can lighting here that the NEC requires that recessed can lighting needs to be marked as type IC, which means insulation contact, or must have a clearance of 3 inches for thermal insulation. And I think that's one thing that has caused some issues out in the field where a AHJ or inspector is reviewing or inspecting a project and he sees insulation contacting the housing of a lighting fixture that isn't marked type IC. So if you do have, this is again coordination with the architect, and to make sure that anywhere you're installing these type of fixtures, whether or not you need a type IC rated fixture. Next, Barrett will talk about the IES.
Hello, this is Barrett. So as Michael just went through a bunch of the code standards, I'm going to touch a little bit on what we call more guidelines and standards. So as a lighting designer versus an electrical engineer, I am constantly referring to the IES 10th edition handbook. So this is kind of the Bible of lighting. It's about 1,300 pages, and it includes sections called framework, design, and applications. So framework is touching on everything from kind of the basics of lighting, including science and technology. Design is touching on more of the design aspects and kind of application aspects, energy controls and economics, and then applications really gets into illuminance recommendations. And I'll show you a small example of what that looks like. So again, in framework, some of these sections are outlined as physics and optics of radiant power, vision, so it really goes into the details of how the eye and brain handle light, photobiology and non-visual effects of optical radiation, perceptions and performances. So this is a little bit about the design and how things are actually perceived versus just the straight calculations or something along those lines, and concepts of lighting language. It also includes color, so it goes into detail about color, spectral color, and how that is really processed in electric lighting as well as daylighting and eye and vision. Talks about light sources, so it's going from everything from metal halide to obviously the LEDs, which are prominent in the market right now. How luminaires are built, so the actual construction of them, as well as optics and how those work, things like reflectors and different lenses. A quick overview of photometry and calculations. The next section, design, again, looks more at the big picture, not necessarily the science and technology, but how to use lighting design. So it goes in detail about the different phases of a typical project and how lighting is really looked at in each of those phases, components of lighting design, light sources in the application side. So again, not really the construction of light sources themselves, but how they're used in applications and where to consider those things. It touches on daylighting and electric lighting, as well as goes over kind of the basics of lighting controls. Obviously, lighting controls is kind of a can of worms these days, especially with all the different protocols and different light sources available, but this really touches on kind of the basics of lighting controls. It also touches on energy management, which is outlined in here, but obviously the codes are going to be dictating what is required in each local section. And economics, so that really touches on payback calculations, life cycle cost analysis, and things along those lines. It touches on sustainability and also contract documents. The application section is a lengthy section of the book. It breaks down into all of these different categories, so art, education, exteriors, common applications, and so on. Each of these sections includes breakdowns in detail of the section type. So for example, if you have a section called reading and writing, which is found in common applications, you're going to end up with all different sorts of reading and writing broken down. So there might be like computer writing, pencil writing, pen writing, things like that break it down in detail about what those light level requirements or recommendations are. So this is a place that as a lighting designer, we're going anytime we're going to design a new project. So going in here, we would take these kind of recommendations that the IES has studied in length and transfer those over to our spaces. So apply them to the spaces that we have in our specific project. An example of that is in this book. So here's interviews. They give the horizontal work plane as well as the vertical work plane. So in this case, we're looking at a formal interview space, which is recommending about 400 lux. Lux, without going into the detailed math of it, is about 10 times as high as foot candles. So in this case, we would assume we're looking at about 40 foot candles at 2 foot 6 inches above finished floor. And then they also give the vertical recommendations. So we want to look vertically at 4 foot above finished floor and make sure we have about 15 foot candles or 150 lux. So again, this breakdown is for many, 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 many item types and many different task planes and goes through all of those different sections. So this is really the guide where we kind of, where to start when it comes to lighting design and making sure that we're providing the recommended amount of light in each of those sections. There are also the IES recommended practices, which come in very handy. These are separate editions, essentially, that touch on specific task areas. So as you can see here, there's lighting for industrial facilities, library lighting, there's recommendations for art lighting, as well as anything from parking and roadway. So these are just kind of an addition to the IES handbook. They really dig deep into some of these sections rather than just the application section that gives kind of a bigger overview of the more commonly used applications. I'm going to hand it over to Michael now, or just kidding, I'm going to do some new construction. So new construction, LEDs are the leading source right now in the architectural market. Most manufacturers are kind of changing their R&D from LEDs over, or from fluorescent to LEDs. So really they are, some of them are still manufacturing older sources, but most of them are actually turning their heads towards LEDs, since that seems to be what's really carrying the market right now. Here is a quick chart. I'm not going to go too in depth to this, but basically looking at the differences between LED, our newest source, versus fluorescent, halogen, and incandescent. So some of the key takeaways, you can see the efficiency is much higher than a lot of other sources. The lifespan is going to also be a lot longer. So in a typical scenario where fluorescent, which was one of kind of the longer sources, is at 20,000 hours, we are more than doubling that with LED, kind of at a baseline. So integral LEDs, which are LEDs built into fixtures rather than retrofit lamps, generally are 50,000 hours plus. A lot of them are even reporting at 100,000 hours, 200,000 hours, and so on. So that's one real takeaway, is in terms of maintenance. Facilities are finding that it's obviously a much easier source to maintain since it lasts so much longer than other fixtures. The annual operating costs are much lower. Again, maintenance is a large factor in that, as well as just the general wattage that's being used. So, your energy bills are going to be much lower. Color temperature, they're available in all the color temperatures that old sources were in, but also provide things like color changing and dynamic color changing fixtures. CRI tends to be a little lower than some of the old sources, but 80 to 90 is still completely acceptable in today's electric lighting market. And some of the even 90 plus are reporting up at 97, 98. So not quite meeting incandescent, which has historically been used as kind of the benchmark of 100 CRI, which is essentially perfect color rendering index. We're getting kind of close to that, but not quite all the way up there. One thing about LEDs is they're directional. So as with a fluorescent tube is kind of the most common one that people know about, light is coming from all different angles. So it's really the reflectors and the fixture design that needs to fully support where the light is going to be going. With a directional source like an LED, they have the same challenges of using reflectors and optics to send the light where it needs to go in a certain luminaire. But without it being multi-directional, that light is really in one location, and it's much easier to work with in terms of using optics, because there's really not too much light in all directions to control, just where the light itself is being pointed. And then dimmable. Fluorescent, halogen, incandescent are dimmable, or halogen and incandescent are commonly dimmable. Some fluorescents are, most LEDs are. So there are a lot of protocols out there, something that is kind of a coordination nightmare in a lot of projects. But there are certainly dimmable ways for LEDs. It's a matter of coordination with the actual control system in your project. So some things we have looked into in terms of what to look for in an LED. We know that, as Michael mentioned before, there's Google, which has a plethora of information, sometimes too much. So one thing to look for is something called an integral LED. So there are LED retrofit lamps, kind of like the one you see here. So many manufacturers make them, and they're on the market everywhere. But if you want a commercial architectural light fixture, generally you want to look for an integral LED. So this means that the fixture itself was designed around an LED diode and does not require the separate retrofit lamp. Something to note that in LEED and WELL, we require a minimum lamp life of 50,000 hours, and some retrofits often do not live up to that, and they're only around 25,000. Another thing to look into, as mentioned before, is dimming. So does the fixture dim, and what protocol is being used? Oftentimes you'll see 0 to 10, TRIAC, ELV, Dolly, etc. And again, this is really a matter of coordination with the project. The control system that you have needs to be able to handle the protocol that the fixture comes in. Okay. Another question to ask yourself is the fixture hardwired, or does it come with a cord and plug? So oftentimes in online sources, there might be cord and plug like you'd see on a table lamp, for example, or hardwired. So hardwired is what you want to be using in more of an architectural application. Something to note here, many newer codes have references to plug loads. So having a fixture that is cord and plug requires that it's in an outlet that's going to be on at any given time and may not turn off from the code. So just something to consider when providing task lights, for example, in a private office. And a few other things to look for. Does your fixture meet ADA requirements? So if you're looking at wall-mounted fixtures and you have to meet ADA requirements, the fixture needs to be 4 inches or less off the wall. Most manufacturers are obviously aware of this guideline, but it's just something to keep in mind. So there are some fixtures that are farther off the wall that may be decorative or used more in like a residential application, but for commercial, you need to be 4 inches or less. Another question is how many tracks can be on the track? So this can be a tough one. If you have a continuous run of track, obviously there's a certain amount of power going to that track. Something called a current limiting device attached to the run of track ensures that the overall wattage of the fixtures on the track doesn't exceed code requirements. So oftentimes this can be done at the panel, or it can be done with a current limiting device that basically tops out the track at a certain wattage. So let's say by code you can only have 300 watts on a track. The current limiting device would ensure that. So if you put one too many track heads on, the track itself is going to shut off. So it really ensures that you're meeting code, and that is what is used in your ComCheck and LPD requirements. Okay, I'm going to hand it over to Michael to talk about renovations and retrofits.
Thanks, Barrett. So for renovation and retrofits, in most cases, an existing lighting fixture is UL listed based on a particular lamp type, such as fluorescence. So that includes the ballast, the lamp holders, the whole 9 yards. And so what happens when you want to upgrade one of these fixtures with LEDs? And I think a common mistake is that if something is UL listed, then it's okay to go ahead and install. But the way UL works is it looks at the entire luminaire as with all the components together for a UL listing. So just because you have a UL listed a lamp, for example, doesn't necessarily mean you can put it in a particular type of fixture, because again, the whole luminaire assembly is UL listed. So LED retrofits can save up to 40% or more. I think Barrett showed on one of her slides table that maybe has even higher percentages. And that's when compared with traditional light sources such as incandescent, halogen, and HID, which is your metal halide and high pressure sodium. So I talked earlier about most likely the fixture that is being retrofitted doesn't have a UL listing with the retrofit LED light source. So what does it take to properly retrofit? So first let's talk about the common types of retrofit. So one is to basically keep the housing, but tear out the guts. Let's just say it's a 2x4 troffer fixture. It's a fluorescent T8. And the typical retrofit would be to change out the guts of that fixture, which means removing the ballast, removing the fluorescent lamps, and installing an LED driver. And in a lot of instances, the entire LED retrofit can just be placed directly into that housing. There's also another type of retrofit where you actually keep the fluorescent ballast, and then you replace the fluorescent tubular T8s or T12s or whatever you have with tubular LED lamps. Now, one thing to keep in mind when you do that, since you're not replacing the ballast and the driver is still integral into the LED tubes, that you're not going to realize the energy savings based upon using LEDs typically, because the ballast is still going to be drawing that same amount of power. So it's important to check with the authority having jurisdiction to determine if the luminaire retrofit kit requires inspection and how compliance is established. And I recommend that you do this at the design phase of a project. You don't want to wait until the inspector is out there inspecting and running into an issue. So UL implies that modifying a fixture by replacing the existing lamps and ballast in the field might negate the UL listing. So the AHJs may require that an LED retrofit kit be UL classified under the product category, luminaire conversions retrofit. And according to UL, these products have been investigated to determine that when used in accordance with the manufacturer's instructions, they do not adversely affect the operation of the complete unit. So I'll give you an example. Let's say there is a fluorescent fixture manufactured by company ABC, and you've got an XYZ retrofit kit. And the question is, can you put that retrofit kit into the ABC manufactured fixture? So UL actually publishes a listing of these luminaire conversion retrofits that are acceptable. So you'd definitely want to make sure that your XYZ retrofit is UL listed with the ABC manufacturer. Okay, so when you're doing the retrofit, it's required that a sticker be put on to the fixture itself, and it basically states that it's been modified. And here's an example of a label that can be put onto the fixtures. Basically, it's telling the maintenance and operations personnel that, hey, for example, if it's a fluorescent fixture, you don't want to change this out with fluorescent lamps. You want to use LED to replace it, because it could have an LED driver that won't be compatible with a fluorescent tubular lamp. Okay, the next section of our webcast is to go over the commissioning of lighting systems. And essentially, what commissioning, and this is the definition from the IES Lighting Handbook. I'm not necessarily going to read all that off to you, but essentially what it means is that commissioning ensures that the lighting control systems that were designed are operating as they were designed. So that makes sense, because you want to make sure that you're realizing all the energy efficiencies. And this is done through functional testing. And ASHRAE 90.1 has actually made lighting commissioning now a requirement. So that's something that has been realized that it's very important to do as the lighting systems get more and more complex. So addressing lighting deficiencies via commissioning has been documented to generate a 1.1 to 4.2 year payback. So when you show that to owners, a lot of owners don't want to do commissioning because they feel that the contractors, hey, they should be installing these lighting systems properly. Well, when you're doing commissioning, you're actually acting on behalf of the owner and making sure that everything is installed correctly. Commissioning lighting systems helps reduce energy consumption and operating costs, and also the benefits include client user satisfaction and acceptance of lighting control systems. So what that means is that if you install an occupancy sensor, for example, in an incorrect location, an occupancy sensor typically has a minor range of movement and a major range of movement. So a typical mistake some engineers make is they locate the occupancy sensor in an incorrect location. For example, in an office, a private office, they may locate it close to the door, but far away from the desk or workstation. So what happens is the occupant enters in the room, the sensor, the major movement senses the movement, it turns the lights on, but in order to keep the lights on, that minor movement needs to be able to detect any minor movement, such as somebody sitting at their desk working on a computer. So you definitely want to make sure for commissioning that those occupancy sensors are placed in the right location. And there also are some guidelines as far as how far they can be away from HVAC diffusers. Another example of where commissioning could pay for itself, we have a project that was a LEED 4 project, and there was a commissioning agent brought on board, and we were the lighting designers. So the owner was complaining that the lights in certain rooms are staying on all night. And the thought was perhaps, even though those rooms were unoccupied, there were specific rooms that had animals in cages in them. So they thought maybe the animals in the cages were causing the light to stay on. But when we all went out there, when the entire team went out there, the contractor, the lighting design commissioning agent, we found out that the lighting control system had been jumpered to, for whatever reason, by the electrical contractor to leave the lights on all the time. So that was actually, once we got out there, it was a pretty simple fix. So that's an example of where your commissioning can improve the client user satisfaction and help you reduce energy costs. So there's some resources for commissioning, and you'll be able to click on these for additional information. LEED requires commissioning, has fundamental, there's also enhanced commissioning. So that's the fundamental commissioning for LEED is, it could be, it may not marry up exactly with the ASHRAE version. So again, you want to make sure that you look at both if you're using both on a project. And then the IES has a publication on the commissioning process. And we'll just talk about that really quick. So there basically are 4 phases. And the most important thing to remember is that commissioning is best done at the beginning of a project design. A lot of times they want to bring in a commissioning agent during construction. I think that's too late, especially if there's some issues during design. So that's the key thing, is making sure the commissioning agent's involved early in the project. Some examples of commissioning of sensors, daylight harvest sensors, where they will automatically dim artificial lighting when there's natural daylight. Occupancy sensors, we went over an example of that in a low voltage relay control system. That's like a time of day shut off. Next, Barrett will talk on dimming for commissioning.
Thanks, Michael. So Michael touched on a bunch of things regarding some of the technical aspects of commissioning, making sure the system is working, making sure sensors are set. I'm going to touch a little bit more on the design portion of commissioning. So generally when we do luminance calculations to determine the correct spacing and number of fixtures and output and whatnot, we use what are called multipliers, meaning some of the output is shaved off of the initial lumen output. So generally, we're taking away about 15% of the light output from day one, if you imagine. So day one, you put a fixture in, it has brand new LEDs that are pumping out light, and it has zero dirt in the lens, anything like that. Over a period of time, at about 15% loss of output, you'll also have things like dust and debris. So really, we're accounting for that to make sure that down the line, 10 years from now, 15 years from now, whatever it may be, the fixture is still going to be meeting those recommended light levels as well as code requirements. So something like that is considered when you go to a final installed project. So if we're calculating a 15% loss, we want to ensure that on day one, we're dimming down the fixtures to meet those levels, if not lower. So there are ways that this obviously affects the aesthetics of a space. You don't want to go into a space that's too bright because you've been accounting for that 15% loss. But it also saves in overall wattage consumption and whatnot. So as you dim the fixture down, you're actually using less wattage and therefore, reducing your energy costs. This is often referred to as load shedding. The LPD is the lighting power density, and that's calculated using the highest possible wattage of a fixture. So if a downlight is 20 watts at its initial output, meaning it's not dimmed at all, you're going to be using those 20 watts. But as you dim them, you're actually using less. So overall, you're actually using less wattage by dimming those fixtures. This is true of residential as well as commercial spaces. So you may be calculating your LPD to stay below code, but you might actually be consuming less than even that code requirement. Additionally, you can extend the lamp life of an LED. So by dimming it, you are actually allowing it to last even longer than that 50,000 hours, if 50,000 hours is what that light was designated for. So you may stretch it out to 75, if not 100, if you're using it, either not using the light for a period of time, maybe sensors are turning it off so the majority of its life, or you're dimming it down on day one to be kind of a slightly lower output. You are only going to extend the life of that lamp. And again, many of today's prominent codes require dimming capabilities, requiring that extra stage of commissioning. So as Michael touched on, it's actually required in newer codes, but it's also just saving the lamp life, energy, and overall money for the client. Now we're going to jump into case studies, and I'm going to hand it off to Michael to start.
Well, thanks, Barrett. So the first case study we want to talk about is Ohio Northern University. It's a new engineering building. So what I listed here were the design requirements. It's ASHRAE 90.1 2010 with Ohio amendments, the 2017 NEC and LEED version 3 new construction. It ended up being gold certified. Now, we had a conflict between LEED and ASHRAE 90.1 2010 with Ohio amendments on this project, where, again, Ohio allows the exemption for the 50% receptacle control, but LEED requires it. So in order to gain our LEED certification, we had to comply with the full ASHRAE 90.1 2010 and could not use Ohio amendments. So this project was done with all LED lighting fixtures, and we used the whole building method on this. When you're doing design with ComCheck, you can select either the whole building method or space by space method, and this came up to 0.45 watts per square foot, 52% reduction compared to the energy code. The lead reviewer actually had commented that he hasn't seen a watts per square foot that low. He questioned it. We had to send the reviewer our ComCheck, plus we had to send the shop drawing submittals of the lighting fixtures that showed what the input watts were so that he could verify what our claim was. This building also has occupancy sensors for lighting control, and again, the minor and major movements, those are very critical to make sure that the occupancy sensors are placed in the right locations, and LEED fundamental commissioning was part of this project to ensure that. And daylight harvesting was also incorporated, and there's a number of the atrium, skylighting, the classrooms all have natural daylighting, so we took advantage and used daylight harvesting. The next project I wanted to talk about is Ohio State University Jamison Sports Institute, and these are the requirements. It's very similar to the engineering building, the same 2010 ASHRAE 90.1 and the LEED version 3. It's got gold certified as well too. So on this particular instance, we used the space by space method just because this particular building had had a variety of rooms and spaces. There were operating rooms, there were offices, there are other support areas. So it led itself well to the space by space method, and it came in at 0.55 watts per square foot. And again, this particular project used all LED fixtures. And LEED fundamental commissioning was part of this as well too, and there's daylight harvesting and occupancy sensors for lighting control. So next, I'll turn it over to Barrett so she can go over her case studies.
So this is NYU Books Library. This was a renovation of their special collections floor. And I wanted to touch a little bit more on some of the design standards regarding this. This did meet code. This project met 2011 NYC Electrical Code, as well as the 2016 NYC Energy Conservation Code. But some of the important things, guidelines and standards that we used while designing this were library lighting, RP, and museum lighting, RP. So these two came in very handy when looking at some of these spaces. This main space is a gallery space. So it had a reception desk as well as these exposed trusses that had decorative lighting embedded into them. But they also did have gallery spaces. So this is kind of an early installation, but you can see that there is a display shelf there that we would be lighting. So some of the things we were looking at were ensuring that we were using low UV sources to not tamper with any of the delicate material, as well as some of those gallery recommendations on appropriate light levels and contrast ratios in these spaces. This was the reading room where students could take some of that delicate material from the storage rooms and bring them out and read them on these large desks. So again, using low UV sources is recommended in these kind of scenarios. And we were taking that into account when designing the overhead lighting. Another thing we did in this space was use current limiting devices. So in this case, we had a lot of track, as you could see in that larger gallery as well, but also in spaces like this, like the locker rooms. So ensuring that we weren't going over capacity on those tracks was very important. The last thing we wanted to do was overlight one of the display walls, for example, and have the whole system go off. And then in other spaces, we had high efficiency fixtures in other spaces like offices, and this is one of the collaborative classrooms. So we just used a simple lighting solution that provided a lot of ambient light. The next project I want to talk about is Suffolk University. This was a project at Suffolk's campus, and we used all LED in this case. Can you advance to the next slide? I lost my visual. We used all LED sources. We were meeting Boston stretch code in this case because it was located in Boston proper. And we were able to use sources such as linear slots in the classrooms where we had a more ambient approach. And then we used wall washers along corridors where we were aiming to light boards rather than just lighting straight down onto the floor. So some of these things helped with our overall energy consumption and kind of meeting those needs. And in the back of house offices, in the offices, we were able to use highly efficient fixtures that provided just general ambient light, but used a lot less energy. They had very highly efficient lenses that were able to provide the high light levels that were required in the open office spaces, but did not consume a lot of energy. So we were able to use more of that energy in other spaces after using the space-by-space method. And the last one I wanted to talk about was the Chalk Autism Clinic. This is a project located in Orange, California, so they were required to meet California's Title 24. It also used all LED sources and came in at just under 0.6 watts per square foot. This project was important that we used low-level dimming. It was for autism patients, so that was a very high consideration. We had to look at the actual clientele that would be in the space. And then some other things we used were presence sensors and daylighting controls. As you can see here in the main lobby, all of these fixtures were tied to daylight harvesting since they were along these large window walls. And then some of the more interior spaces, we were able to use highly efficient fixtures that gave a lot of ambient light and, again, saved that pressure's wattage for some of the front of house spaces.